Hi everybody, I am about to go on vacation. Yay! I've been sitting in this chair for 16 hours and I debated just walking out of here, but I don't want to leave. I'm going to be gone for 10 days. I didn't want to leave without doing a little bit of this iPhone 10 stuff that I've had planned for a couple days. So I want to just show you, I've got a couple of iPhone 10 boards here. I want to play around with them a little bit and show you how to work on the iPhone 10. So let's start with the iPhone 10. It is the teeny little baby board that's actually a sandwich of two different boards. So you have to, step one, split the two boards apart. So this is the one, this is Manny's board that Manny was kind enough to leave with us. We did some fun work on it at the course. But first I've got this other board that I'll show you how to split this apart. When I split Manny's board, I use this cool, very cool hot air nozzle that's made for the Quick. So the Quick hot air station that we sell at iPad Rehab Supply, we just got 50 new ones and they are ready to go. So finally back in stock if you want to pick up your Quick hot air station. I used this nozzle and it was super easy because the hot air nozzle is designed for, it's an exact fit here for the iPhone 10 logic board, the two halves. It just fits, right on top of that. But this time I'm going to just see, I don't know how useful that was, and so everything at iPad Rehab Supply we like to kind of vet and try it out. So I'm going to try out on this one just using kind of regular standard hot air and see how that works. Now the tool holder I really do like. This is made by my buddy Wyman, so from G-Lon. So Wyman sent this to me, and what I like about it is that it is a stencil to put the board back together at the end, because at the end we're going to have to put a stencil. And I love this is magnetic. Isn't this cool? So we would put the bottom board, and then this is a magnetic stencil so that we could reball and then solder the two boards back together. So I really like this thing also to hold the board when we split it apart. So I really like that tool. Let's see if we can give this a go. Now the solder that's holding these two together is a low melt, so it is a lower temperature. I'm gonna just go down to about really low. This is for me 80 degrees under my standard temperature. So let's see if that's too low to split these apart. So I'm just going to kind of go around and around here with my regular nozzle. Actually, I think I'm going to go with a bigger nozzle. So I'm going to go with my large and in charge JBC nozzle. Well, let's see how hard this is to do. We're just trying to heat these up generally. Now what I like about this stencil is that it will let me kind of get in here right at that level to split these apart at that interconnect board. So with the, when I did this before, I think it was much faster. So I think that's telling me that I need to go up a few degrees. So I'm going to go up a few degrees. I'm going to go up a little bit of airflow as well. Has the repair community found some common issues with the iPhone 10? Well, I think the iPhone 10 is still a little premature. We won't really see them until they start coming off of warranty or until they start getting screen replacements and then start getting water damage. Now the season of water damage is starting to come upon us, so we may start to see some, I have 3 here right now, which is unusual. Prior to this week we'd only ever seen 1. So it may be becoming a thing. No, I kind of like, I think I might actually go back to the specialty nozzle. I mean, it's possible that I'm trying to do it in the wrong spot, just out of sheer fatigue. I don't think so. You know what? I think I am going to take the time to swap back and go back to this specialty nozzle, which then makes that pretty cool. Let's see. I think this board is actually pretty easy to separate, so it really shouldn't be this much effort to split these boards apart. So let's drag over a quick, and let's make some space for it. So we're just going to use the quick to pop off separate this board, split it apart. Alright, so we're going to use that specialty nozzle. Isn't that cool? So cool! And that's going to go just like that. Alright, so let's turn this on. So I'm putting this on 300 on the quick, which might be a little high. Can you guys see that? I hope. I'm pretty sure that's the spot to separate it, but I probably should have checked. There we go. Eee, that one looks green inside. Alright, so there we go. So I think that with less fatigue that is easier. But whoa, that is not bode well for water damage. So water apparently can go straight in between those little spaces in the interconnect board on the iPhone 10. As evidenced by the fact that this one looks so mossy that I can see it all the way from over here. So let's move this out of the way, and we'll just kind of glance at this board. All right, so I'm going to say that I'm a fan of that. I'm a fan of that nozzle tip, and we will begin stocking that at iPad Rehab Supply. And that's what we like to do, just try out different things. Okay, all right, let's have you guys take a look with me. This one we're just going to glance at. The one that I want to fix is the other one. So let's put to sleep the hand camera, and let's put to sleep the schematics, and let's take a look. Yeah, so this is water damage on the waterproof iPhone 10. Dun, dun, dun. Yeah, I'm surprised, honestly. I'm surprised that this much water can get in between, you know, can invade the screen, can penetrate and get in here. This is bad. This is bad. That's bad. All right, so one of the questions that we get a lot with the iPhone 10 is, hey, are all of those little nubs, the interconnect pads, are they just spacers or what are they doing? And these are, not all of them, but some of them are required. So I have two tools here that I'll probably try out in a future video that will let us test. So if we did some repairs, cleared out some shorts in this baseband board, then we have some tools that'll let us test without fully reassembling. All right, so the next step for this board is ultrasonic cleaning, and that's all we're gonna do with that one. Now let's talk a little bit about Manny's board. So Manny brought this to school from Costa Rica. He just came to Practical Board Repair School last week. And then he left us this board because it seemed like we had so much fun playing around with it. So let's look at Manny's board real quick. I'll leave it here in this little red doohickey. All right, so Manny's board was, in theory, water damaged, but it doesn't look like water hit the board. So we had a hard time finding water damage. We found some, but it was super, super minor. So if you look at this board, this is all of the RF stuff. The only stuff that looks grungy is actually normal. That's just the thermal paste, the thermal compound. Considering that it probably won't dry out, better if it gets water, or if anything, it could be worse. Could this finally get some people to stop believing in the rice myth? No one will ever stop believing in the rice myth. You know, I should do a better job probably stamping that out, something more experimental. All right, so that side of the board is the RF board, like the baseband side, and then this is the main board. So let's look at the main board, and we've done some measuring around. This smudge stuff is just nothing. You know, that's just thermal compound or flux or something like that. But you'd be hard pressed to say that this board saw water at all. In fact, we concluded on our first initial exam that this board was not water damaged. So this is the other inside. This is the CPU. This side faces internal. And then this is the top side of the board where all the connectors are. So this is the side of the board that kind of faces out. And we really didn't see any signs of water on this board at all. All right, so let me kind of catch you up to where we left off on this board. So the first thing you're gonna do with an O-Power board is you're gonna have to have a way to connect it to DC power supply and see what kind of a state is it in. So how are we gonna connect it in DC power supply? In fact, working on the iPhone 10 is like memory lane back before ZXW. It's not on ZXW, not the main board. Back before schematics were searchable. We've got a schematic, but you got to just use your eyes. It's not very searchable on the board view. And, you know, the squid that I use every day doesn't have an iPhone 8 or an iPhone 10 connector. So what are we going to do? So it's back to basics. So first is to figure out where's the battery connector. That's pretty easy to figure out. That's where the battery plugs in. Next is to figure out how the heck am I going to be able to inject battery power into this thing when I don't have a connector. The first thing that I did didn't work out, but it was a good try. I took an iPhone 8. iPhone 8 and iPhone 10 are a match for the battery connector. And I tried to make a little DIY connector. I took the one for the iPhone 8. That's not this one. You know, and I soldered it to one of my squids and plugged it in. Didn't work for very long. All right, so then next is we're gonna have to solder a wire. So let's do that. So let's solder a wire and see if we can inject some voltage and see what kind of a fault we have here. All right. This one was really, really fun in class because we're pretty sure that we know what's going on now. But it was one of these ones where I said, okay, let's try one more thing about, 10 times. And let's do one more thing. And in the end, we made a finding on it that was just based on experience, applying experience learned from other boards to the iPhone 10. And that's what made it such a cool thing. The iPhone 10 schematic is cool. It's got all sorts of new chips, new friends, friends yet to know. All right, so the step one here, you're gonna have to connect some power. So how are you gonna figure this out? So let's look at the connector. So we can guess with our multimeter in just straight up continuity mode. Let's just guess. Looks like a mess. Reminds me of the old battery corroded arcade boards. Yeah, battery corrosion. All right, I'm just gonna stick a probe here on ground and say, what's ground? Hey, look at that. That plus is ground. That was a bit of a troll. Ground is also ground. These end brackets are ground. So that's ground, that's ground. And then over here, this is battery positive. Now, what does battery positive connect to? Because I don't want to mess up this connector. And the answer is this cap here. So this is what we already figured out. There's ground, and this is the battery positive side of this cap. So we're going to knock that cap off and just actually use that pad there to solder to. So let's stick a wire, and this will be our wire that will be our way to inject into battery. And from that, we'll be able to see what kind of a current consumption pattern we have. And that's going to be our kind of our guide. Okay. All right, so let's check to see, does that wire have continuity with what we believe is battery positive? All right, so we'll stick a probe here and here. And do we get a beep? Yes. And not to ground? Yes. Okay, good. So we have a wire hooked onto VCC battery. iPad rehab, I hope you get better soon. Yeah, me too. Me too. I am going for the first time to Paris, France tomorrow. We're going to go to Paris. We're doing the like Beaches of Normandy World War II tour. I have not even looked at a guidebook. I have absolutely no idea what's going on. Anybody that has any tips for Paris, let me know where to go, where I don't want to just stand in a line. I'm taking 4 kids to Paris to see some history, see a city, see what's up, and not be at work. Too many of these 16-hour days, just not even fixing anything. Most of the 16-hour days are rabbit hole days like this, where you're just trying to figure stuff out. Okay, so now we have this connected, at least in theory. So let's go back over to the hand cam and take a look at the good old DC power supply. If we can, I got a new like stand for this thing, which is even crappier than usual. Sure, here, why don't you stand up, hand cam? I think you got some space. Will you situate yourself? Here you go. There you go, buddy. All right, so we're going to prompt it to boot. Now, how are we going to prompt it to boot? Well, we've got a couple of ways we could try it. One is I can plug in a dock. So I did harvest a dock out of one of these, and we can plug in a dock. The other is to figure out where the power button pin is in the connector, which we figured out as well. All right, so we're going to prompt to boot with DC power. Prompt, prompt, prompt. And it is doing that. What the heck does that mean? So when I prompt to boot, it's flickering around like that. Flickering around like that. Honestly, that looks a lot like how an SD RAM short looks like on the iPhone 7. See that sort of just flickering up high? So let's go with that really, really high flicker means that we probably have a short on this board somewhere. Let's see if we can get the same result from going in the power pin. So let's get rid of this, look under the microscope, and yep, I get the exact same behavior when I just kind of touch these pins together. All right, same behavior. Okay, so what does that tell us? That tells us that we have some kind of a short circuit. But where? No idea. So one of the first things that we tried was to see if we could find what line was short by visual inspection. Nothing jumped out at us. The next thing we tried to do was to figure out what kind of, whether we could find a shorted line by just doing heat to see if anything got hot. So we put freeze spray on this board and we followed around. We got trolled by our buddy, the Boost IC, which let's see if I can remember where that was. We got trolled with the Boost IC, and it was a fantastic course week because so many things kind of made sense. I'm pretty sure it was this guy here. That is the VDD Boost. Now, VDD Boost is a line that was new with the iPhone 7 that was not in the iPhone 6 or 6S, where it is a VCC main or VDD main branch that is active when the battery is very low. So it's this little boost chip that will take battery voltage and turn it into main with a coil to boost it up. Clever idea to help you out when the battery is very, very low. But it makes it so that just like the battery main MOSFET, this is battery to boost, it's going to get hot even though it's not the source of the short, because it's kind of the restriction point and current is rushing through this dude in order to get to the actual short. And so this thing will tend to get hot. So that was, we could not find a short, none of these were short around here. We couldn't find a shorted line, and of course we're not going to just take a chip off because it's getting hot. Our question is what line is short. So that's when we pretty much almost gave up, where we didn't have, there was not a short on main that we could tell. There was not a short on boost that we could tell, and we didn't have any ideas. What would you guys do? What would you guys do next? Let's see. Jessa, any good channel suggestions on Samsung and other Apple PCB board repairs? Yes, iPad Rehab channel or Mark Schaefer. Mark Schaefer's channel. He streams most of his Samsung stuff here on iPad Rehab channel, but he has some probably on his channel. Use the milliohm meter. Well, that doesn't help us tell what line is short. Our question is what line is short, not what dude is short, because we don't know what line is short. Let's see. Oh my God, hi Jessa. Let's see. You will absolutely hate Parisian people's attitudes, Jessa. They think their shit doesn't stink. I don't think that's true. We'll see. We'll see. Pump in amps. Nope. That only is the only thing that will do is make the Troll Boost IC heat up. So this is what was fun about this board. This was about the point where we said, nothing else here to learn. Let's go back to the pile of solvable stuff. Who knows what's up with the iPhone 10? But when we were doing this in class with Manny here and everybody from the course on the last day, when we would put freeze spray on the board, and that would kind of change things a little bit, the DC current consumption changed. It stopped being straight up to that 1 amp. It changed to a more steady value that we had seen before. So as it happened during course week last week, we had seen early on in the week, I think on the Monday, we had seen an iPhone 6 that happened to have a signature problem of sudden death on 3VO NAND short on the iPhone 6. And then later in the week, we saw an iPhone 7 that similarly had the Boost IC heat up for no reason. And then we discovered that it also had a short on the 3V0 NAND power rail. And the current consumption pattern was very similar between those two. And just sort of as this last thing to apply, I said, let's ask the question just by pattern recognition. If maybe this iPhone 10, maybe it also has a NAND power line that just kind of happens to go bad. So let's just check, before we put it away, let's just go check on 3VO NAND in the iPhone 10, just from applying from one device to another. So how are we going to do that? How do we even ask the question? Does iPhone 10 have the 3VO NAND power rail? I don't know. So let's go dig up the schematic and see what we can make out of it. So the schematic is in two different documents. It's the iPhone 10 schematic itself and the board view. Let's just say, is there a line called 3V0 NAND? Or let's just look at NAND power. Ha ha! There is PB3VO NAND. No, this is the same, 3V3 out is the NAND power rail in the iPad mini that goes short all the time. This goes short in the iPhone 6, this goes short in the iPhone 7. And the reason is bad cap almost always, and it's almost always on the edge of the board. So let's just see for chance if that's what's up with this line here. Just because we know there's a short somewhere and we don't really see any physical damage. All right, so that means we can pick any of these caps as a way to test the line. So all we have to do is find any one of them. So let's look for 2613, 2616, 2619. And you guys will have to help me out because I have been working 17 hours in a row and am really, really tired. So help me find on the board view 2613 or 2621 because I don't remember where they are. Okay, so now we can't search. We've lost our magical control F. We cannot type in C26, 12 or 13. It doesn't matter. None of this is text searchable, so we don't have any way to find this other than use our eyes. And last time I checked, which was on Friday on ZXW, that was also not an option. So we just have to use our eyeballs. This is what we were doing. It's old school. Help me find it. Help me find it. Go home, go to bed. Okay, will do. Sounds good. I see a clue. All right, give me the clue, B Pope. Give me the clue. Is this one of them? Is it? I've already forgot. This is gonna be really hard for me to remember numbers from 1 second to another. Yeah, we're all looking for one of the 26s. It was really amazing. Pablo at the course was like, there it is. He had this amazing ability to instantly find these caps. All right, these are all C27s. Ooh, here we go. C26. Is it one of these? Is C26? Is it 2602, 29, or 30? Is that it? 2602, 29, or 30? Nope, 31. All right. C2634, is that one of them? C2634. C2634, that's one of our guys. So C2634, this little guy on the end. So now we just have to figure out where the hell this is. All right, so this is up on the side with all the connectors. There's a guy here, C2634. Actually, the one I think that we were looking at was a corner guy. Was it C? Let's see. Let's see if I can just remember it. So we found one of them. Yeah, I think it was C2616. It doesn't matter, but I just kind of thought that was an easy one to measure. Yes, C2616. There we go. There's a match. This one is easy to measure. That other one I'm pretty sure is covered in underfill. All right, so let's go to the CPU side and find this guy, C2616. Okay, now we got something to go on. So let's go on a hunt. So we're just guessing. Hey, does this line happen to be short just from pattern recognition on other dudes? All right, so here we are here's the big CPU, here's the power management chip, and this is our cap that's on 3VO NAND. So we're just doing a quick test just to ask, hey, does 3VO NAND happen to be short in the iPhone 10 for no reason other than just stone cold guessing from pattern recognition. So we'll do a diode mode measurement. Now in all the devices that we know, the 3VO NAND power rail ends up being about 0.3 or 0.4 on diode mode. So let's just see what this one is. So we're going to go red probe on ground and measure here. All right, 0 on one side and the other side. Sweet doggy, look at that cold, lucky guess. Luck or skill, you decide. So that is a pretty strong finding. We know for sure. And we did compare to one of our other iPhone 10 boards. And in the iPhone 10, that line should be about 0.386 or something like that, like it always is. So now we got a lead. We got something to do. And just applying that, we saw that 6 in the course, we saw that 7 in that course, and now here in the 10, same line is short. And we found that just by recognizing how the current consumption pattern looked on DC power and applying that with what we already know. So that was pretty awesome. So now, why is that line short? So we could either look for heat or look for the ugliest guy. So let's vote the ugliest guy off the island. That's gonna be tough because we don't have that zillion times work. We're gonna be a zillion times slower because we're gonna have to find these suckers by hand. Boo, 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 by hand. So now we are back to this sucky problem where yeah, we gotta find any one of these guys could be the reason why 3VO NAND is short. So any of these caps could become a wire to ground, or within the NAND itself. That would be bad. So one of these caps or the NAND, and let's just say does 3VO NAND power rail go anywhere else, and it goes here from this is where it's generated from the power management chip. Anywhere else? No. So power management chip, row of caps, or the NAND, and that are all of our choices. So I will speed up for you guys and show you what we found. We did hunt each one of these dogs down by eyeball method, and we found it. Let's see. Repair 100, luck 10, lucky skill. Can't we just blast voltage and freeze spray? No, we can't. No, we can't. So let's see. I forget which one it is, but I'll take you on a tour. Let's get rid of this dude. I don't see why everybody is so against banging the table. I think everyone should bang the table, you know, at least once a week. All right, here we go. So now as we look around on a hunt for these things, we found here at the corner. Dun, 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 dun. Look at that. Now there's a little shade of the silicone waterproofing all along here. Dun, 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 dun. And then look at that. Holy smoke. That right there, ladies and gents, that's bona fide water damage. And this one is bona fide water damage with bonus fucked up looking. So that's the ugliest guy on the island. What are the odds? You know, we didn't see it. Like, there's nothing else wrong here. There's no corrosion. I mean, everything's covered up. Nobody's messed up. There is no corrosion. Doesn't look anything like that one we just took apart. But look at that. That one spot. Look at that. That is water damage. That's not just random or technician damage. That is water. Now, where is this in the iPhone 10? I'll show you just so that you can know. Because who knows? Maybe this is the beginning of a signature problem. This is how you find signature problems. And the students were really like, you know, I could tell that they were kind of like, why don't you keep this to yourself? And the answer is because, you know, maybe we find something cool here today. I'm counting on you guys to find something cool tomorrow or all 10 days while I'm on vacation. Post in the comments, go to It Takes a Village on iPad Rehab forum and tell people about it. Because here's the thing. This is a $1,000 phone. I mean, it's a piece of crap, I'll tell you. I have one. It's the worst phone I've ever owned. I hate this phone. But if we all find these like little oddball findings and post about it, you know, kind of say, hey, what's up? Hey, I found this. Then maybe the next time you get one, you'll instead of being like, oh, I can't devote my life to any one phone, look around, I don't see anything, move on. If you can then solve your customer's problem, that's good for me. That's good for all of us. Because the more customers out there that kind of think, hey, I'm going to go to the local shop and get board repair, the more board repair outreach that we can do on a local level, the more people that can walk in and get their TriStar audio ICs fixed and get their water damage, you know, their unbacked up pictures saved. That is good for all of us. And we have a chance to work together and be able to come up with this. What are the signature failures for the iPhone 10? I have no idea, but we got to work together. If we figure them out quick, then we'll all be able to recover phones that have a really high value. If it takes, you know, 3 years, nobody's going to want to fix the 10. Nobody's going to want to split apart the board and solder it back together. everybody's just going to pass. If the phone doesn't have enough value to fix, it won't make sense. Now, where is that spot? Here, I'll show you. Look at that. So the board that, the spot that we're examining is right here on the edge, right here on the edge of the NAND, and that board fits in right here. So look at that. That spot is right at the power button. So it is a spot where there could be like a way for water to get in or under pressure, something like that. On this one in particular, it looks like there might be a defect at the seal, maybe. Yeah, see on this one, there's this little flattened down piece of solder that looks like it was pressed flat in the ceiling. Something tiny like that might have let a tiny bit of water get in right there. Alrighty, so now let's look up and see exactly what are these two dudes that look water damaged, and see if they, one or the other of them or both, are a match to our line. Let's do it. All right, so let's get back to that schematic page, and we're gonna check out the board view. All right, so let's get back to the schematic page. Nope, let's get back to this page. Yay. All right, that's hella funny, Jessa. Crest iPhone size cleaner, deer and rabbit repellent. Link seems to be wrong. Alrighty. Let's find the CPU, which is on this other page. Right, here we go. Right here on the edge, dun, 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 the two guys in question are C2645 and C2649. Are either of these guys on 3VO NAND? Let's find out. C2649 and 2645. 2649, ding, 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 and 2645, no. 2649, hello, winner, chicken dinner. Look at that. That dude is on the line that we found was short. So let's take a guess. Why is that line short? It's because of that guy. So that I thought was pretty cool. So what to do? It's time to vote the ugliest guy off the island. C2649, you gots to go. You gots to go, my friend. All right, so let's get him off there. And that will probably be my stopping point. This board may very well have other things wrong with it, but I thought that this was just a really cool finding, and I wanted to share it with you guys, because who knows? Maybe this is gonna be a really common spot for well, look at how damaged that is. Well, that's like quite damaged. In fact, I need a little flash of heat to get that out. What does C2645 go to? That is a great question, and that one we can answer. Now, C2645 doesn't look more than, kind of, yes, it got hit by water. It doesn't look like damaged. And our question would be, well, it looks like it's definitely a cap. Wow, that's a serious burn hole. That was pretty much on fire. I mean, that is the kind of serious up short that has damaged the actual substrate of the board. Look at that. Let's drill down on that. Sometimes you used to see shorts like this on the good old C5202 in the iPhone 6, and they would actually cause internal shorts, where layers of the board were fused together. That's severe. All right, so as far as I'm concerned, that should be fairly cleared out now. All right, so the other guy, I doubt that guy is short. Let's see. Red probe on ground diode mode. 0.244, so whatever he is, 0.244. Now let's just first go check and say, is our 3VO NAND short now relieved or not? Maybe that was a total troll. So is our short relieved? And we are at 0.403. So yes, 0.403 on 3VO NAND. So we have put out one fire. Now the the question that Eddie asks, which is, hey, where does that other dude go? Let's go ahead and answer that. It's a good question, just to see. Maybe that guy is a signature problem on another phone. So C2645, we can search this way. C2645 we should be able to find. C2645, show yourself. C2645 is a 1v8, a 1v8 cat. Now 1v8 is in general in all the other phones. I don't know about the iPhone 10, but the 1v8 is kind of your brain stem power line. That's what your power button is powered off of, all your data lines out of the CPU. So that in general, a 0.244 value seems reasonable. So that sounds like that line is good. All right, so now let's see whether or not we have anything going on with this phone. Let's see. Let's get rid of this. Let's just go all the way because I'm super tired. Let's go hand cam and let's see what happens. Let's just make this go down to the desk. Down to the desk. Get under there. Move this. God bless it. Raining soldering irons all over the place. All right, that's like not any better at all. All right, that's gonna have to be tilted. All right, there you go. So, is anyone else that does YouTube like balance stands on trash cans and things like that, or is that just me? Just me? All right, there you go. Okay, so let's take this board. I'd really like to know how these things work, but I think I am too fatigued to figure it out. Let's give it a try and see. This is its bottom board. This is the top board. And it fits together like that. And then I think it has this thing. I'm not sure how I'll get my ground on there. What I don't understand about this one is it has some way to attach battery, but that goes to a bracket that sits on the bottom of the board. I don't really get it. So something is wrong on that I'll have to put some thought into on a day where I haven't been here this long. Let's see. I think the idea of these little sandwich makers are really cool. So I have two, and I don't really know how either one of them work. So that will be a future video of comparing these two. Both of them I got from Union Repair. They sent me one of them for free when I was asked them what's the difference. They were like, why don't you figure it out? Okay, will do. I did see they had like one video where the guy used it, but he kept calling it the iPhone X instead of the 10, and that was driving me crazy. When I first got this phone, I found it just impossible to say iPhone 10 instead of iPhone X. But I got my iPhone 10 under duress. I swore I would never get another iPhone. I loved my iPhone 6 though. Rest in pieces. And then Good Morning America called me and said, hey, you want to be like our expert for iPhone 10? We're going to drop it off some buildings so you can open it up. Sure. I had never seen an iPhone 10 before in my life, but I'm not going to say no. So I said, sure. All right, so I have, my wire is still working, at least in theory. So I said sure, and that meant I had to then go buy an iPhone 10 toot sweet and take it apart. Figure out how those suckers worked. All right. Sorry, camera. Here, go over there. There you go. All right, hang out. All right, where's some ground? Now it's kind of hard to find ground. Can you be some ground? I'd hate to have to solder a wire to ground. Can you grab it right there? No? Fine. Are you ground? Maybe. Alright, I'll just touch it there when we need to. Alright, let's just see what happens if we were to prompt this thing to boot. So I'm just going to touch ground. And we are going to watch DC power. I'll let you know if anything goes on. All right, so now, ooh, look at that DC power supply says DC power supply has a fairly normal looking current consumption. I'll do it again for you. I'm going to let go of my ground. I'm going to put ground back. This is so low rent. Oh my God. There's like, this stand is just a nightmare. I think I'll have to go back to the other one. Whoa. Low rent. I like the 5 series design the best. Me too. All right, so I'm going to prompt to boot. Prompt to boot. Let me get my ground back on here. All right, prompt to boot again. There we go. Now look at that current consumption. Look at that. That looks like a phone that gave a little flicker, like a little Apple logo, and then went to DFU. So that 80 milliamps, that's pretty standard for, hey, I'm working, my CPU's fine, but I don't know what to do, I've lost my instructions. Perfectly acceptable outcome from living with a short on the power line to your hard drive, which is what this phone had. So that's definitely progress compared to how this originally was. And my guess is that if we put this all back together right now, we would find that this phone would be able to boot into DFU mode. In fact, it might even be detected by iTunes right now. And it is! Listen to that! So I don't think I can show you guys this, but let's see. Yep, iTunes has detected a phone that's in recovery mode, so in DFU mode. So that 80 milliamps is telling us that this phone is in DFU mode. So that's great, and this phone is not for data. This is just trying to fix Manny's phone. And what we do know about the iPhone 6 and the iPhone 7 3VO NAND short is that sometimes it will come right back if you solve the short. Other times it will require restore, because what has happened is the power was pulled out to the NAND, the hard drive of the phone, and just like if you did that on your computer, sometimes you could pull the power, plug it back in, everything would boot up fine, but every now and then you've corrupted your data. So I think this is really consistent. So with this one, I'm going to stop this now because this was the finding I really wanted to show you guys. It's fun, it's new, there's so much to learn, it's fun to explore the schematic. It is hilarious in the iPhone X schematic with the new chip names Racer and Romeo and Juliet and Acorn and all our new friends. The tools are fun, taking apart the board. We're going to have some new challenges on soldering it back together. So when I get back, I will solder this one back together and test it out and ask the phone to go ahead and restore. And I'll see if I can figure out what's the difference between these different little jigs that let us do testing on the iPhone X before putting it together. So that is what I wanted to show you guys with this. Jessa, what if the short 3VO line comes from the NAND itself, not from the caps? That would be very unusual. In fact, I've never seen that. So I've seen, that's just not how that line fails. If it was the companion line, the 0V9 or the 1V8, then that does fail as an internal short within the NAND. The 3VO line, that's not how that line fails. You know, if it did, then something very atypical is going on. So if you have a short within a chip, you know, the problem is what the problem is. You can't make the problem be the problem you want to solve. The problem is what the problem is. So you would have to solve the problem that there is. If you have an internal short into your NAND, you can just hope that you can still read the serial number so that you could program a new NAND. But otherwise, that would be the end of the line for it. All right, I would start there also. Something about a bunch of ear speaker. Any damage to the connectors on the board. Sounds like you guys are talking about something else. So that is that's it for today's iPhone 10. And let me know if you're working on an iPhone 10. If you solved one, tell me about it. I want to hear. We want to gather up these signature problems because it's going to be a while before we start to see these routinely. And when we do, we want to be prepared and we want to know where to look. How do these guys typically fail? And we want to be able to hit the ground running because we've got a lot more work to do with this split board. So that is it for me, and I will see you from the other side of my Paris trip in about 10 days.